Hi, my name is Brian Gracely, and in this next installment video about cloud computing, we're going to talk about some of the basics, the technologies that underlie what happens in cloud computing, both from the infrastructure perspective, the software perspective, the operations and management perspective, and we'll talk about both how these are delivered through open source software technologies, and we'll also talk and highlight some of the vendor technologies that are behind this. Now, we're going to keep these videos as vendor independent and somewhat technology independent as possible, but I will point out both market leaders and community leaders within the technology spaces so people have some context when they hear us talk about technology broadly and they read the news headlines and they see discussion about a vendor or open source community project name or some trend that's happening in the industry. So let's talk about cloud computing, and we're going to keep this to begin with. We're not going to focus this on private cloud or public cloud or some variation of sort of terminology. We're just going to talk about the technology building blocks. And sometimes it helps when we're talking about new technologies or new concepts to relate it to an existing analogy that people are used to. So let's look at, since we talked about cloud computing, let's look at computing the way that most people are used to hearing about it, or that, an analogy that whether you're brand new in the industry or you've been in the industry for years and years, you'll understand this. So if we take any computing device, it basically looks like this. It's going to have a set of hardware, and that hardware is going to be made up of CPU and memory and BIOS and all the things that are within that device. So it gives me a way to display it, it gives me a way to process it, it gives me memory, it gives me storage, and to a certain extent it gives me a network element that allows me to connect one computing device to another one. Right? So that's the basis of what I have in any computer, a laptop, a smartphone, a desktop device, and that's been the case for a long time. Now, on top of that, you have an operating system. Now, we're familiar with things like Linux and Windows and Unix, and that operating system in essence provides two things. One, it provides a way to manage the hardware, and it also provides a way to manage the application, or to allow the application resources, and we'll talk about applications, to be able to leverage the hardware resources underneath it. So for the application to manage memory and be able to access the CPU and be able to access the network resources, naming, all those other things. That's what operating systems do. And then on top of that, we've got applications. Okay? And these applications could be anything. They could be very, very small applications. They could be huge applications. They could be applications that consume a small portion of one computing device, or they could be applications that really are meant to be clustered or distributed and actually leverage many, many types of hardware devices. But these are the basic premises of what we have within any computer or computing device. Okay? So if we use that as our premise for what happens in cloud computing, the only difference is we have the network, and then to some extent I've got a user of some sort, and this user could be a human being, or to some extent, in some cases it may actually be I'll represent it as a user that's a bunch of ones and zeros, which really is maybe another application or another source of data that's going to interact with this thing. So when we talk about cloud computing, we really have very similar makeups. We'll just use a little bit different terminology so that as we go further in these videos, we'll help connect the dots. So instead of hardware, we still have the network. The network is going to be the thing that's going to interconnect all of our cloud computing resources and our cloud computing applications. So that doesn't change. It's going to be an TCP/IP network, whether it spans an internal network within a building, multiple networks, or across the internet. Okay? So first thing we'll have, and I'll call this infrastructure. And just like we had hardware as sort of the underlying basis for a computing device, our infrastructure is going to be made up of servers, storage, and then the networks that interconnect those things. So these might be storage networks, or data networks, or some sort of convergence of data and storage networks, but really that infrastructure, and then also the things on top of it that make sure it's secure. So firewalls, load balancers, intrusion detection devices, all of the sort of hardware infrastructure, cables and so forth that allow multiple devices to interconnect, multiple devices to monitor traffic, access the network, access resources appropriately. So we've got this sort of direct correlation between hardware in an individual device and infrastructure for a cloud. Okay. The next thing we have is instead of having an operating system purely, we tend to have what are called like development environments. And a development environment is something that developers are going to leverage in order to be able to write their applications. And so this is where you see things like your development languages, so Java and Ruby and Perl and Python and all sorts of other things, PHP. But then you also see development environments. So you see .NET for Windows environments. You see Java Spring or Java EE. You see a bunch of other things for the other programming languages, whether it's Ruby or Perl or whatever it might be. Okay, Scala, whatever. But you've got basically the languages that developers want to program to and the frameworks that support those languages. Okay? That draws a correlation between the operating system, again, being able to manage what happens with our applications, and how we deal with the underlying resources. Okay? And then the third thing we have within any cloud computing environment is we have the applications. And these applications could be legacy types of applications that have been ported to these new environments. They could be new applications that are written to be distributed. But again, the applications are the way that our users, whether those are individual human users or machine to machine, are going to interact with the application, and more importantly, they're going to interact with the data that lives down here in the infrastructure somewhere, okay, whether that's on a server or in a storage array or somewhere else. Okay. Now, the last thing that maybe doesn't draw a complete correlation to an individual computer, but if this was a network of computers, you'd have a layer of some sort of management that's going to keep track of all these, whether it's keeping track of the devices themselves or it's keeping track of the operating system for security reasons, on top of, or really maybe sort of surrounding all of this environment, is going to be kind of a management and operations framework that's going to allow all these resources to work together and to work in a way that's very, very unique for cloud computing, or sort of this new model for cloud computing, in which these resources are consumed, they're provided to an application, they're consumed, they're given back to a pool of resources in a dynamic manner. So instead of thinking about fixed resources, a computer, a set of servers, they're still made up of those underlying pieces of hardware, but the operations and management sort of layers, the software that's built into there, and the APIs that live in all these spaces, the way that we're able to programmatically deliver these resources, take them back, expand them as needed, contract them as needed. This is really the core piece that in a lot of cases people tend to call, cloud. But this is what a normal cloud stack would look like as opposed to a computing stack. Okay? So you can sort of see the natural correlations between what is hardware and infrastructure, what is the OS and sort of development environments, what are applications and how those map to each other, and then where management and operations, whether this is called orchestration, automation, dynamic provisioning, management, all those sort of words and those functions become a very, very important piece of being able to say, whenever I want resources, I can get them on demand. It means I don't have to ask IT organizations. I don't have to ask a procurement office ahead of time that I need these resources. There's a procedure and a policy in place that says when I want X amount of resources, I can get them for my application, for development, whatever that environment might be. I can be charged for those things on an on-demand basis. So instead of thinking about I bought this specific piece of hardware or I bought this specific piece of software and whether I use it 1,000,000 times in 2 years or I use it 3 times in 2 years, I'd pay the same amount here. This is going to be billed or charged or made, traceable back to somebody on an ongoing usage basis, so I can, or a on-demand basis. So I have a sense of how much of the resources did I consume, how do I associate cost to those resources, how do I align that back to a business demand, a business challenge, or a business need. And a lot of that is going to come from this part of the cloud stack, really, really important component of it. But when we're trying to wrap our head around, what's really happening inside the cloud, the analogies between what we're used to from a computing perspective and how things, correlate in a cloud computing environment aren't that hard to make the leap between when you're trying to compare the two things. Now, let me highlight a couple of things. We're not going to get too deep into this, but a couple of things that are very, very different about cloud computing and really the evolution of applications in cloud computing. Okay? The first one is that resources are going to be dynamic. Okay? We're going to have resources that are going to be dynamic. And by that, what we mean is I don't have to call somebody on the phone. I don't have to wait days, weeks, months for resources to be cabled, acquired, cabled, provisioned, and set up a certain way, and then allocated just for me. There are going to be resources that have been pre-built, pre-provisioned, pre-populated, racked and stacked and cabled, and operating systems put on top of them and so forth, that when I want to go use them, I can typically go to a self-service type of environment, a self-service portal, a web page that's going to allow me to say, here's the set of resources that I can get to, whether those are applications or their development environment or their servers and infrastructure. I'm going to have a self-service way for me as a user, me as a line of business, me as a developer, to go say I want to consume those resources, right? So IT has given those to me, or a service provider has provided those to me as a service on demand. And all these things are going to be on demand in terms of billing, in terms of usage, and on demand in terms of if I need to grow them or I need to shrink them. So let me give you an example. This is a common example that's used. If I'm a retailer, so I'm in the consumer retail business, I sell clothing, I sell records, I sell whatever I sell, music. Most of my business might be fairly consistent throughout most of the year, but come the holidays, especially Christmas time, when people are trying to buy gifts, or say Mother's Day if I'm in the flower business, or Father's Day if I sell golf clubs, whatever it might be, my business might be fairly consistent throughout the year, but I have, every once in a while, I have a large peak that I have to be able to manage. Well, that can be very, very challenging if you don't have your resources available to you. So to be able to manage those peaks and to be able to bring those resources back in line is what this on-demand means. And I'm going to pay for the peaks, just like I pay for the rest of the resources, but I'm not having to pay this level for all these months when nothing is being used. So that's really what on-demand means. So dynamic resources, I can get them as I need to. I can get them on a self-service basis. They're going to be on demand, and we're going to operate them a little bit differently. We're not going to necessarily provide every single feature and functionality and nerd knob and widget, and we're going to provide things that are common, that can be dynamically provisioned, that can be automated, that can be reusable through across a bunch of different applications. So if application 1 is using some resources, and then application 2 comes along, and application 6 comes along, and application 2 gets turned off, and I've got to be able to reuse those resources in ways that I can service lots and lots of business needs and lots of application needs. So hopefully, as we think about kind of the underlying technologies for cloud computing, there's a direct analogy that can be drawn between what we used to know from traditional computing, or individual computing devices, to the operating system and development environments, hardware and infrastructure, and between applications from a computing environment to what we call a cloud. And we can draw those analogies, but really the big change being the management and operations to be able to deliver dynamic resources, on-demand resources, and self-service resources for my applications, for my infrastructure, and for my development environments. So hopefully this gives you a good basic understanding of the technologies underneath cloud computing. For some of you, you'll say, oh, well, those feel very, very comfortable. I've been using those core technologies for a long time, and it feels like the real difference is how they're operated, how they're provisioned, how they're operated and managed, and on an ongoing basis how they come in and out of service. And that would be a very, very true statement. So we'll get into more detail about what are the actual technologies that deliver these elements. We'll also talk a little bit more about the actual vendors and open source technologies that exist to deliver these things. But we want to give you a basic foundation for what's under the covers for cloud computing to allow this, whether this is a private cloud environment or a public cloud environment, or eventually what people tend to call a hybrid cloud environment where it's a mix of both resources. But those are the types of analogies, those are the types of technologies that you want to be thinking about as you're starting to dive more into cloud computing. Thanks, and thanks for watching this video.